So here's my setup. Okay, so we'll start off by drawing a portion of the membrane, if you will. Basically, we just label this extracellular, and then this will be the cytosol. So basically, start out. It's a horrendous membrane. We got exon 1, a mutation in which results in elimination of that overall exon and part of the LDLR. Exon 1 is a part of the signal sequence domain. So that is responsible for getting the LDLR to the membrane to bind with LDL. So basically out here we have a bunch of LDL floating around after it comes in from food or whatever kind of consumption that brings this into the body. We have our Golgi, Golgi right here, and then of course like coming from the ER. So we'd have our LDLR go through all its processes, transcription and synthesization. I definitely butchered that. But basically, with no signal sequence, of course, it won't be able to come into the cell to attempt to bind to the LDL to bring it in. So the LDLR, you could, guess how close it gets, but if this was the LDLR, it would just remain floating within the cytosol, unsure and undirected of where to go in order to bind with the LDL. That should, over time, eventually probably lead to it being degraded because it's not serving its purpose and fulfilling its function. The cellular process that is affected by this would be the receptor-mediated endocytosis, which again is the process of just bringing the LDL into the cell, which would be mediated by the LDLR after it would bind to the LDL, which you can't do if it's not guided there. So to segue into our next exon, which is exon 5, which is a part of the domain, the ligand binding domain, either or. It's part of that domain, so it's responsible for binding to the LDL. So basically, since you could say that the exon 1 is not mutated and eliminated, but rather the exon 5 is, so it would be able to be guided to the membrane. So the LDLR could make it to the membrane, but it would be unable to bind to this LDL because of the mutated exon 5, which is responsible for ligand binding. So that would result in the LDL just continuing to float out here and never be able to bind to this LDLR to enter the cell. So again, the cellular process being affected by this is receptor-mediated endocytosis. For both of these processes of the mutations involving exon 1 and exon 5 that are affecting the receptor-mediated endocytosis, since the LDL will remain outside of the cell in the bloodstream, it'll basically, for human consequence, it'll result in the person having elevated cholesterol levels in their blood.